Hello everyone, it's Benny, and welcome back to the 3D Game Engine tutorial series. In this video, we're going to be focusing on the little things. We're going to be going through our list of Wolfenstein 3D notes. We're going to be checking off the things that we've already done or already started on, and then we're going to work on some of the smaller things on this list. And that'll sort of be the calm before the storm in the next video. You'll see. So first off, let's just go through the list, starting from the top, and see what we've already done. We have a rendering engine now, so go ahead and check that off. We have a way to insert the game into the engine. And in effect, we have better scratchpad support. We don't have better textures yet, but we do have some way to separate the game and engine data. All the game is divided into the scene graph. All the engine has its own system. We do have higher level rendering constructs. We're mostly focusing on shaders, materials, and meshes and transforms in the game system. We have some form of automatic shader selection. The rendering engine passes it down. Don't have primitives yet. We do have a more flexible transform class. Don't have non-perspective views. Don't have texture manipulation or control. We don't have more friendly constructors, or the more window properties, or the better vectors math, or options. But we do have some sort of centralized level system. That's what the scene graph is for. We do have a game object system. Haven't named all the positions position, unfortunately. We haven't made the naming more consistent or had vector swizzling. We haven't made the time based on that, or given that new stuff to vectors. We don't have transparency support, or sprite support, or a way to compare vectors, or anything else. So yeah, these are the things we've done in the last couple of videos, which is some pretty decent progress, but, you know, I'd like to, well, do a little bit more. We're not adding a physics engine in this video, or making better textures, or adding primitives. We might add some non-perspective views, though. But, in fact, yeah, let's go ahead and just start with that. It's as good a thing as any to start with. So the way this is going to work is pretty straightforward. And I managed to screw it up. So let's try this again. I'm going to start by copying the init identity method, just so I have sort of this grid here set up for me. And I'm going to go right below init perspective and paste. And here's what we're going to do. We're going to create an alternative form of projection. So rather than just being able to initialize a perspective projection, we're going to be able to initialize an orthographic projection. And this is going to have some left, right. So what we're essentially doing here is we're defining a cube, or a rectangular prism. So we're going to define the left position, the right position, we're going to define the bottom position, the top, the near, and the far, and float far position. There. So that should give us all the information about this rectangular prism that we're going to project our scene into. And the first step of this is we need to know the width, height, and depth of this. So I'm going to take the width, which is right minus left, the height, which is top minus bottom, and the depth, which is far minus near. There. Now here's how we're going to project everything into this rectangular prism. It's going to be done in two steps. First off, we're going to scale at all the points in the scene, everything in our scene, so it fits in this, well, in this width, height, and depth of this prism. And then the second step, after we've scaled everything so it fits into the prism, is we're going to translate everything so it's in the position of the prism. And that's how this is going to work. So, here's how we're going to scale it. We're going to start by taking the width we already have, and since everything starts in a range of -1 to +1, that's going to be 2, and we're going to take that, and we're going to divide it by our new width. And that's it. That's everything. That should put everything, well, onto the proper scale. We're taking our previous scale and dividing it by our new scale. That should work. And after we've done that, we're going to do, well, the same thing for every single axis. We're going to do 2 over height for the y-axis, and 2 over depth for the z-axis. And there, now everything should be scaled to the width, height, and depth of our prism. The second step is translating it, and this is where things are going to get a little bit weird. You'll see what I mean. So, brace yourself. Now to translate it, what I'm going to do is something a little bit interesting. I'm going to take my right and add my left for my x-axis. And what this is going to do is this is going to sort of tell me how offset it is from the center. So for instance, if I have a right of 1 and a left of -1, it's going to be 1 plus -1. So therefore, it's centered and no translation is necessary. But if I have, say, a right of 800 and a left of 0, then it's going to give me 800 plus 0, so I'm going to know, oh hey, I need a total overall translation of 800. And there. And now since we are going to be working with sort of normalized coordinates where everything is -1 to +1, I am also going to want to divide this by width, so that, you know, everything's still properly in this range. Well, you know, in the -1 to +1 sort of scale. So there. And that's how I get the amount of the translation. And we do the same process for x, y, and z. So, except of course with top and bottom, and far and near, and with height and depth. You know, there. And one thing you gotta be careful of is if you just do things like this, then everything will be backwards. Or not backwards, it'll translate in the opposite direction. So you actually want to do this negative. And the reason well, it depends on how you look at it as to the exact reason, but if you're looking at it how I look at it, then the reason it needs to be negative is because you're translating from this positive cube back to the -1 to +1 normalized coordinates. And that's why it's sort of backwards translation. You have to go negative because you're going from the end position to the -1 to +1 range, not from the -1 to +1 to the prism. That's how it works if you think of it like I think of it. And there's one final really tricky thing here, and that is you can't just do it exactly like this, because what you're really ultimately doing is you're creating one matrix of the scale and one matrix of the translation and multiplying them together. And when you do that, you get a few weird artifacts. And one of them is, or the big one, is that depth ends up being negative in, well, the scale portion of the final multiplied matrix. If you don't believe me, go ahead and multiply it out, and you'll see that it does indeed get negative on depth. But yeah, that's just one of the weird things about, well, matrix math in general, I guess. It will make depth negative. And there, that should create an orthographic projection. I'm not actually going to do anything with this matrix just yet, with this way of initializing it, so that'll be saved for later. But for now, I'm going to go ahead and initialize, or at least have the method here, so I can do it whenever I want to go ahead and do it. And one final thing before I go. In the last video, I did window.getWidth over window.getWidth rather than window width over window height. So yeah, make sure you change this to window height. This right here, to window height. Or otherwise you'll run into some weird projection issues. So yeah, and now back to the normal video. So, I can go ahead and I'll add an equals there to say, you've done some stuff, but we need a little bit more. Now, more friendly constructors. That can be done, so core engine I think is pretty okay here. Yeah, it's pretty much exactly what I want. Game, pretty much exactly what I want. Game component, all that's pretty much exactly what I want. That's static class, so don't need anything of that. I actually really like the way the matrix initialization system's working out, so I'm going to leave it like that. Quaternion, I'm going to save this until we're focusing more on quaternion stuff. Rendering engine, just exactly like I want. Time, that's static. Transform, I think we can change a bit. And while I'm at it, I'll change this to POS, ROT, and scale, just to make a more consistent naming system. So, there. And, yeah. I know that was on the list, and it's not, well, it's not what I'm focusing on, but I want to go ahead and do it. And, yeah. It's just while I'm at it. Change this to get position. In fact, isn't there, like, some refactor tool? Yeah, here we go. Refactor, rename this. There we go. Change this to get pos. There. Now I don't even have to think about it. So, change this to set pos. Yeah, go ahead and do the refactor. I'll change this to position, just be consistent. Change this again. Pretty simple here. Yeah, there's not too much in-depth stuff going on in this video. But wait till you see the next video. This is all sort of in preparation. Or maybe even the video after, but hopefully I don't have to go that far. Scale is fine, though. Just need to change this here. So, to pass. There we go. And there. So now we've renamed all that. Now for more friendly constructors, I'm going to leave transform alone for now, actually, because I think what I'm eventually going to do is just have transform initialized in a different place from where I actually set the values. So, yeah, I don't think I'm going to need that. Vector 2f and 3f are fine. This stuff, attenuation and whatnot, it could be better, but I don't want to do it right now. Base light, again, could be better, don't want to do it right now. Basic shader, camera's fine, directional light, again, could be better, don't want to do it right now. I want to save lighting stuff for later, and you'll see why. Material. Oh, that already has some pretty decent constructors. Okay, I'm going to leave it like that then. Mesh, just fine, actually. So I'll leave it like that. Let's see. And is everything else? Oh, texture? That's about what I wanted at. Vertex is fine, and pretty sure, yeah. And window, that's static. So, whoops, close the notes. So yeah, just go ahead and close others. And say, now I can say, yes, I do have more friendly constructors. And now, window should have more properties. Okay, window. So I said here it should have a center position, possibly full screen and mouse locking. I'm going to add center position here, so yeah. So public vector 2f. There we go, 2f. I'll call it get center. You can return a new vector 2f of, yeah, get width over 2, comma, get height over 2. There. Very simple, and we need to import it. That's fine. So there, very simple. Getting the width, getting the height, and all that's done. So good, just very basic, get in the center. As for mouse lock, however, that's going to be a little bit different. Well, not that different, but different enough. You know, I actually think I might do this later, just because right now I'm handling mouse with input. So yeah, I'm going to save that for later. Whoops. That's not where I have the notes. So yeah, I'll go ahead and give this an equals for now, so I started on it. Better vector math. I might do that in this video, but I'm just going to leave it there for now. Name all variables position. Okay. I'm actually going to name them just pos, because I think that's clear enough, and it's not as, well, ridiculous to type out. So yeah, I'm just going to say get pos, which is what camera has, it's what transform has. And unless I'm mistaken, I think that's everywhere I refer to it. So I think I can go ahead and check this off. Make naming more consistent. I think it's pretty consistent right now. I'm going to go ahead and check that off. Again, I'm going to do a little bit more of this later when I do shader stuff, but for now. Vector swizzling. Okay, this could be interesting. So swizzling. That I can do. Under vector 3f, I'm going to have some public vector 2f get xy, which is going to return. How should I format? Okay, whatever. Return new vector 2f with x comma y. And this is really what swizzling is like. In fact, I am going to put it on one line just because this really doesn't need two lines. It's explanatory enough by itself. Get xy, get yz, and get zx. So this is going to return yz, this is going to return z and x. Pretty straightforward. And I also need another one, because I still need these reversed. So yx, zy, and xz. And that should be all of them. So there, that includes Swizzling. And xz, there. Oh, wait, what? Oh. Get yx. Excuse me. And... oh, no, that's fine. That's exactly what I want, actually. So there, that includes Swizzling. So I can go ahead and check that off. Because I can't really do any Swizzling with vector 2f right now. Make all time based on seconds. Okay, it's about time. I've been getting pretty fed up with this. I'll be honest. So, yeah. I'm gonna make this vect private right here. Return nanotime divided by double second. There we go. Cast this to a double. There. Much better. And also, eventually I'm going to get rid of these. I might do that now, actually, but you know, for now I just want to build and see everywhere that screwed something up, because yeah, there we go. So, here we go. Now I can finally start doing this. So, double last time. I'm gonna get time. Start time, past time. And unprocessed time can be just plus equals past time now. Now, if frame counter is greater than or equal to 1, I can actually do, because, well, it's all based on seconds. There. Is everything else here? Well, let's build, and let's see if this has broken anything. Don't think I've broken anything, but you never know. Okay, updating properly. Cool. So I can successfully say I've made all time based on seconds rather than nanoseconds. And also, I'm going to actually add something here. Change the way delta is passed. Because I want to change that a bit. You'll see. So, give vectors a copy constructor. I want to save that for a later point. Give vectors an interpolation method. I can go ahead and do that. That's pretty straightforward, actually. So, can add public vector 3f lerp, which takes in some vector 3f of destination, and some float lerp factor. This is very simple. Going to return dest.sub this times the lerp factor. So there, and then I'm just going to take that and add this. There we go. That's lerp method. Going to do the exact same thing in vector 2f, wherever that is. Here we go. I'll put it here. Why? Yeah, why not? So it's going to be vector 2f. And that should do... There's no subtraction method? Oh, because vector 2f dest. There we go. Okay, cool. Vectors have an interpolation method. Not going to do that right now, or that. Good way to compare vectors? Sure, I can do that. So, I'm just going to add... Yeah, I'm going to add one method for this. Public void equals, which is going to take in some vector 3f other. It's going to return x is equal to other.getx, y is... oh, right. And y is other.getY, and z is other.getz. Okay, cool. Oh, right, and it's a Boolean method. And this should override, shouldn't it? Oh. I guess there is no equals method in object. I was wrong, sorry. I thought there was. I can do the same thing in vector 2f. Just go to the bottom and do that. Or I can change the mate from projects tab. I can move that too. Yeah, but it's going to take some vector 2f over. And there. Cool, got a good way to compare vectors. And I can go ahead and add vector 2f cross product, and that should be just about everything for now. So public float cross vector 2f other. And this is going to return x times other.getY minus y times other.getX, I believe. I'm actually going to double check that in a moment just to make sure. But yeah. And there. And do I have time for that? One moment. I want to check time and make sure I actually got this right, these parameters right. So one moment. Yeah, I mostly got it right. I should just probably rename this to R just to be consistent with everywhere else that I used this. I don't know why I didn't do that. So yeah, just go ahead and change that to R. Okay, good. I'm going to do the same thing in vector3f. Change it from other to R to be consistent with everywhere else that I've done this. So... okay, cool. So with that, I do want to do one final thing, and that is I want to get rid of these get and set delta methods. And I'm going to fix all the errors that come up. You might be wondering, well, what on earth are you doing, Benny? How on earth are you going to get deltas if you never use them? Or you never set them like this? And it's very simple. I'm going to change this to be base, or to... I'm going to change my game to take in some double delta as a parameter. Actually, I'm going to make it a float delta just, you know, because I'm probably going to want to cast it to a float anyways. But yeah, I'm going to change that. It's going to pass in delta to the game objects. And the game objects, they're going to take in some float delta in input and update. And that's going to pass in delta. So yeah, I'm just going to pass it as a parameter. And that way I don't have to have a big scary static class there for that. Which is good. That shouldn't really be what you do. And it also means that camera's going to take in some float delta, when it's going to multiply by this instead. And game component, oh well, I don't know, I probably should have delta here. So yeah, probably should. Now I can change mesh renderer to take in float delta, because that's where the logic's going to be, and that's really where it's going to get used. So yeah, and okay, so now all I have to do is change this to passing in frame time. And there, that should fix the delta conundrum. Almost. Mostly. What? And cast it to a float, because passing it as a float. There, and that should fix most issues. Not all of them, but most of them. Oh. What? Oh, transform. Transform. I deleted that somehow. There. Now if I build. Here we go. Now I can pass it in. Good. And now it should build, and now it should run just like before. Oh, nope. Still forgot it somewhere. Delta. And this takes in float delta. It's temporary. That doesn't matter that much. And core engine, where are you? I know, this video is running a little bit late today as well. Sorry about that. It's going to take float frame time, just like everything else. Now if I build, it should run, and everything should work out just fine. Okay, so now if I run... okay, cool. It's working just fine, so I can go to the time class, I can get rid of all this. In fact, I'm probably going to get rid of a few other comments off screen, like, for example, these, because I don't need these at all. So yeah, those can go away, and these can go away, and this can go away, and this can go away. So there. And with that, ladies and gentlemen, that completes the calm before the storm, before next video, where we're going to start adding lighting to our rendering engine, and things are going to get a little more complicated than they have before. So yeah, you'll see. You'll see. So hope you're excited for them. Thank you. Hope you enjoyed. Hope you learned. And see you next... oh, wait, almost forgot. Right here, gonna go ahead and add a check to that. So there. Now, thank you. Hope you enjoyed. Hope you learned. and see you next time.